Let's delve into the fascinating world of chemical reactions, specifically two intriguing experiments that illustrate fundamental concepts in chemistry: the reaction between magnesium and hydrochloric acid, and the reaction between sodium thiosulfate and hydrochloric acid. First, let's consider the reaction of magnesium with hydrochloric acid, a classic experiment that showcases the production of hydrogen gas. When magnesium metal is introduced to hydrochloric acid, a single replacement reaction occurs. Magnesium, being more reactive, displaces the hydrogen ions present in the acid. The chemical equation for this reaction can be expressed as follows: Mg plus 2HCl yields MgCl2 plus H2. In this reaction, magnesium chloride is formed along with hydrogen gas. You can visualize the process. As magnesium strips are added to the hydrochloric acid solution, you'll notice effervescence, or bubbling, which is indicative of hydrogen gas being released. This gas is colorless and odorless, but it can be identified by its characteristic pop sound when a lit splint is introduced to it. This sound is a result of the hydrogen gas igniting, a clear demonstration of its flammable nature. The rate of this reaction can be influenced by several factors, including the concentration of hydrochloric acid and the surface area of the magnesium. A higher concentration of acid increases the number of hydrogen ions available to react, thus speeding up the rate of reaction. Similarly, if the magnesium is in powdered form rather than as a solid strip, the increased surface area allows for more collisions between the magnesium and the acid, further accelerating the reaction. This experiment not only illustrates the production of gas, but also emphasizes the principles of reaction rates and the factors that affect them. Now, let's shift our focus to the second experiment involving sodium thiosulfate and hydrochloric acid. This reaction is particularly interesting because it results in the formation of a cloudy precipitate, which serves as a visual indicator of the reaction taking place. The equation for this reaction can be written as Na2S2O3 plus 2HCl yields 2NaCl plus H2O plus SO2 plus S. In this case, when sodium thiosulfate is mixed with hydrochloric acid, sulfur dioxide gas is produced along with water and solid sulfur. The solid sulfur is what causes the cloudiness in the solution. This phenomenon can be observed quite dramatically. As the two solutions are combined, the initially clear liquid becomes increasingly opaque, transforming into a milky suspension. The rate at which the precipitate forms can also be influenced by various factors. For instance, the concentration of sodium thiosulfate and hydrochloric acid plays a significant role. Higher concentrations lead to a faster rate of reaction and a quicker formation of the precipitate. Additionally, temperature can affect the reaction rate. Increasing the temperature generally increases the kinetic energy of the molecules involved, leading to more frequent and effective collisions. Both of these experiments reveal important insights into the nature of chemical reactions. They illustrate how reactants interact, how reaction rates can be manipulated, and how visual indicators can provide evidence of chemical changes. The production of hydrogen gas in the magnesium and hydrochloric acid reaction exemplifies a gas evolution reaction, while the formation of a precipitate in the sodium thiosulfate and hydrochloric acid experiment demonstrates a precipitation reaction. In conclusion, these two experiments not only serve as excellent educational tools for understanding chemical reactions, but also highlight the beauty of chemistry in the way it allows us to observe changes in matter. By studying these reactions, we gain a deeper appreciation for the processes that govern the interactions between substances, and we lay the groundwork for exploring more complex chemical phenomena in the future. Chemistry is not just about equations and formulas. It's about understanding the world around us through the lens of science.